All right. I know that some of you are still working on your performance task. However, we have to change gears here so that we can somewhat stay on track as far as laid out in our scope and sequence. We are getting ready to start our polynomial unit, but before we dive deep into our polynomial unit, we're going to review the factoring concept that you should have left Algebra 1 knowing. Remember, we said we're no longer going to say what we should have left Algebra 1 knowing. We're just going to teach it, right? And so, with that being said, even though it says factoring review, I do understand that it may not feel or look like a review to you. You do not have to announce it to me, okay? I don't need to hear the story of how you learned or what took place in the class. I've accepted that we are where we are. We're going to be taking the notes directly in our handy notebook. If you're not in a position where you can see, you can always turn on the Zoom. But if you're in a position where you're fine, then just look up on the board. So with all that being said, on each page, we're going to be using 75 and 76. In our notebook, you're going to divide each page into 6 sections. How you divide them is up to you, but you're ultimately going to have a total of 6 examples per page. It's a new 6 weeks, so you can literally just call it 75. Call it a day. I just, okay. All right. So we're on 70. Are we on 75? I think I'm 75. Right?
Well, it says that 75 is the word for the homework. So
Which homework?
the 3A.4.
Oh, I forgot about that homework. So we are 76, 77. I totally forgot about the homework that we didn't count. Whoa, that counts. Not in our notebook check. Lo siento. I think I wrote it right on your actual Canvas page, just not in my notes. All right. So let's go ahead and get this show on the road. All right. Our first 6 problems are going to be over factoring using GCF and simple trinomials. Can someone tell me what GCF stands for? Greatest common factor. So we're going to start off using the greatest common factor. So when we're talking about method number 1, if I say method number 1, I'm referring to the greatest common factor. Remember, the greatest common factor is the largest number that evenly divides into your terms, right? It's the largest number or variable, in this case for algebra, that evenly divides into your terms, okay? So we're going to, Nope, I'm going to tell you when to write. All right, so we're on our first box. So using GCF, this is our first box. We have 15m squared minus 9. And we're going to go through the steps of factoring using GCF, okay? So in our first box, we have 15m squared minus 9. And we're going to go through the process of factoring. When you are factoring, you are separating literally your factors, okay? So you're going to have 2 pieces that come together. The first thing you're going to do is find your GCF. You're going to ask yourself, what is the largest number that I can divide into 15 and 9? What would be the largest number I can divide into 15 and 9? Into both, yes. That would be 3, right? We agree? Because it's your greatest common factor. And the greatest common factor is 3. When you divide, you're going to be left with what's called your quotient. So once you establish what the GCF is, you're going to divide each one by the GCF. So you have 15 divided by 3, which gives us 5. And we already have the m squared there. And 9 divided by 3, which gives us 3. When you rewrite your answer is going to always be your GCF times your quotient. If you get rid of either part of that, you're producing a different value, a different expression. So to get your final answer, you take your GCF, and our GCF is 3. So we're going to take 3, and we're going to times it to our quotient, and our quotient is 5m squared minus 3. So our factored form would be that. It's the GCF, exactly. When you're writing your factored form, it's your GCF times your quotient. Someone, I know I said I wouldn't ask anymore, but can someone please give me an inkling, an ounce of hope that you guys did learn this in Algebra 1? An ounce of hope that you did do this in Algebra 1. That you did. There's an ounce. Okay. All right. Now, let's talk about when it's numbers and variables that are GCF. When you're looking for the number and the variable, when there's numbers and variables, you're going to compare numbers with numbers, variables with variables. Okay. The key thing to note that when you are dealing with variables or your variables, GCF equals variable with smallest power. We're in our second box, right? So when you're comparing variables, it's going to be the GCF is equal to the variable with the smallest power. Okay? The reason being is if I have a higher power, when I divide out, I'm not going to be able to divide both equally, right? I'm going to have not enough in some aspect. Okay? So let's start here. We have 5x squared plus 10x. Again, you're going to look at the GCF of your numbers first. What is the GCF of my number? 5. The greatest common factor of my numbers is 5. Okay. Next, we're going to look at the GCF of our variable. Our variables is x squared and x. Looking at the GCF for your variables is looking at the variable with the smallest power. When there's no power, it's Casper the friendly one. When there is a power, then you're going to go. So what is our smallest variable? X, just x to the 1. Does that make sense? Okay. Now you're going to divide. When we divide, that helps us find our quotient. Okay. So we're going to divide by 5x, divide by 5x. A lot of times people are doing this part in their head, which is perfectly fine. 5 divided by 5 is 1. X squared divided by x is exponent rules. It's just 1x, right? When you're dividing, that means you're subtracting. 2 minus 1 is 1, correct? 10 divided by 5 is 2. And x divided by x is going to be 0. So my quotient is 1x plus 2. Your final factored form is always your GCF times your quotient. What was our GCF? 5x. What was our quotient? X plus 2. So my factored form would be 5x times x plus 2. Because it's 1. X is still there. It's not x to the 0. Because it was x minus x to the 1 divided by x to the 1. I have a factor in the numerator and a factor in the denominator. So what are they going to do? They cancel each other. They equal 1. They become Casper the friendly one. Okay. Now, if you're unsure if you did it correct, the beauty of both of these problems, I'm going to go backwards for a second, is that you can check yourself. Okay. The opposite of factoring is distribution, and vice versa. The opposite of distributing is factoring. They are each other's opposite. So if I wanted to check myself, I would just redistribute. What is 3 times 5? 15. Is that 15n squared? Yes. What is 3 times -3? -9. Did I do it right? Yes, I'm a genius. Okay. Same thing here. The inverse operation of factoring is distributing. Inverse of distributing is to factor. So I'm going to check myself here. Does 5x times x equal 5x squared? Yes. Does 5x times 2 equal 10x? Yes. So what does that tell me I did with my factored form? I did it right. Okay. Now, we did 1 and 2 together. Guess whose turn it is? Yours. So in the third box, you're going to write down the following. You have 4x to the fifth minus 6x to the third plus 14x. You're going to find the GCF and the quotient so that you can find the factored form. All right, let's see where we're at. So on the first part, you're looking for your GCF. Remember, numbers with numbers, variables with variables, right? So we have 4, 6, and 14. What is the largest number that divides evenly into those three numbers? 2. So our numerical GCF is 2. Okay. Now we're going to look at our variable. Our variable is x to the fifth, x to the third, and x to the 1. What is the smallest x value that we have? X to the 1. Agree? Now, the reason why I saw that some of you were still trying to figure out what this means. If I have x to the fifth, that means I have 5 x's. If I have x to the third, that means I have 3 x's. If I just have x, that means I have just 1 x. What's the most they have in common? They all have just 1 x, and that is why your GCF is just x to the 1, which is why we say it's the variable with the smallest power, because I can't divide more than what my smallest is. Okay? When you're dividing, that means we're finding our quotient, because the operation of division is the result is the quotient. So when I'm going to divide numerically everything by 2. Okay? Variable wise, I'm dividing everything by x. Okay? 4 divided by 2 is 2. X to the fifth divided by x means I'm taking away 1x. So when I take away 1x, how many am I left with? 4. So that becomes x to the 4. 6 divided by 2 is 3. X to the third divided by x means I'm taking away that 1x. When I take away that 1x, how many x's am I left with? 2. So that becomes x squared. 14 divided by 2 is 7. And then x divided by x means I'm taking away that x. When I take away that 1x, what am I left with? No x's. Okay? Your expression, your factored form, so when we're rewriting, we're writing it in factored form, is going to be your GCF times your quotient. Our GCF was 2x, and our quotient is 2x to the 4 minus 3x squared plus 7. If I am not sure that I did that correct, that's where I'm going to do a little bit of mental checking. I'm going to ask myself, is 2x times 2 4? Yes. Is x times x to the 4th x to the 5th? Yes. Is 2x times -3 -6? Yes. Is x times x squared x to the 3rd? Yes. Is 2x times 7 14x? And the answer would be yes. So what does that tell me? I'm a genius, and this is my factored form. Okay? Yay? Huh? Because that's your variable GCF. The lowest x represents your variable GCF. What do your variables have in common? Okay? I'm glad that you accepted this as Algebra 1. Yes, it is. But we have to make sure we can do this in order to do the Algebra 2. All right? Okay, so we will pick up on this on Thursday. We'll finish doing our factoring review. And hopefully we're golden.